Chapter 4, we start going into integration now, or what's called antiderivatives, also known as integration. And integration is the opposite of taking a derivative. If you notice here on the sheet here, I would like you to actually pause the video, and I would like you to think about this for a second here. All right, I want you to think about what was the original equation before we took the derivative to get 2x. What would have I had to have had to get the derivative to be 2x? I want you to pause the video and I want you to think about each of these and try to come up with a system that you use. And then when you're done, play the video and I'll go through the answers here in a little bit. So now that you've thought about that for a second, hopefully you came up with, all right, when we take a derivative, we bring our power down and then decrease the power by 1. So we would have had to have x squared, because when we took this, our function would have had to have been x squared, because we bring our power down and decrease it by 1 to get 2x as our derivative. All right. Well, to have just an x, we could have had as our derivative, we bring our power down, all right, and then subtract the power of 1. Well, we ended up with an x, so we should have had an x squared to begin with, and if we would have brought a 2 down and to end up with just a 1 out top, it would have had to been x squared over 2. Because if I take the derivative of x squared over 2, I'd bring my power down, and I'd get 2x over 2, which would just be x, right? Okay, so what would we have to do for c? C would have to, again, this power was already subtracted by 1, so we'd have to add 1 to it. All right, in order to end up like this, we would have brought our 3 down, right? And subtracted this power by 1. Well, we just have a regular, we just have a 1 coefficient here, so we would have to divide by 3. So we would have had x cubed over 3 for that one right there. For D, what would we have needed to get x to the negative 2 as our derivative? Well, we subtract our power by 1, didn't we? All right, so we'd have to add 1 to this power, so we'd have x to the negative first. And here we have a positive, all right? So if we had x to the negative first, we would have brought this derivative, we would have brought this down, we would have got negative x to the negative second power. But if you notice on our original equation, it's not negative x. So our original equation, this must be a negative outside here. Negative x to the negative 1 power should be D. All right, well, same thing for C. Let's look at, or E. Let's look at E. How would we get our derivative to look like x to the negative 3? Well, okay, so this is a derivative, which means we subtract the power of 1. So we're going to have to add the power. We have to add 1 power to the negative 2. All right. So if we were taking the derivative, we would have brought our negative 2 down. We would have brought our negative 2 down and subtracted the power by 1. Well, we just ended up with an x cubed is all we ended up with. So we would have had to, in order to get to this thing, we would have had to divide by a negative 2, right? So they cancel out just to get x to the negative 3 power. So those cancel out there. And then we ask ourselves for f, well, what did we take the derivative of to get cosine? Well, the derivative of sine is cosine, so our original function should have been sine. So we have to kind of put our brain in a little bit of a reverse mode to figure out what antiderivatives are, or integrals. And actually, you'll find there's some pretty easy systematic ways we go about finding integrals. Here's a theorem right here. Now, not something that I hit up above. It says anytime we take an integral, all right, f is we can actually, there's many types of answers that we can get. Like if my derivative up top, when my derivative was 2, and we took the integral, which the integral sign is this, and we'll get to that in a second. When we took the integral of 2 and got 2x, so that would have been our original function, would have been 2x. Well, if we think about it, I could have had a function equal 2x plus 10. And when I took the derivative, I'd get my derivative would be 2. But I could do another one. I could add another function. F of x equals 2x plus 1 million. 1, 2, 3. Okay? And I take the derivative of that, and I'd still get 2. So what we're saying is this C can be any constant. We don't know what it is. It could be anything, because when we take the derivative of the constant, it disappears. So when we take the derivative, we're going to get, or when we take the integral, we're going to get 2x plus C. C is what's called the constant of integration. Because it could be anything, we don't know what it is. So we're going to put it in there. All right. And then the general antiderivative is what we just talked about. My general antiderivative is going to be, and my general antiderivative is going to be when we take the integral, and we're going to add C to it. That's the general one, the general family. And so the general solution. So this would be a general solution to the integral of 2x would be x squared plus c, because when we take the integral, we have to add c to it, because it could be added or subtracted any constant that we can think of. All right. And one last vocab here is differential equation, an equation that involves x, y, and derivatives of x and y, like y prime equal to 3x, or y prime equal to x squared plus 1. That's a differential equation. Let me show you real quick on your cheat sheet. That whole calculus cheat sheet, we have a whole place for integrals. And here's some basic properties of integrals. If we have two functions added together, like x plus 2, we want to find the integral of that. We can take the integral of x plus the integral of 2. That works very much the same as derivatives. All right, and here's that plus or minus 1 right here. Well, this is a definite integral. Sorry, this is the one that we're dealing with now. All right. And so here are all our properties and stuff like that. And we'll get to more of those later. We're just now introducing you to derivatives, or integrals. Okay? So they want us to find a general solution of the differential equation y prime equal to 2. So what they're saying is they want us to take the integral. So the integral of 2. We're asking ourselves, what would have been our function? All right, what would have been our function if we'd taken the derivative and we got 2? What would have been our function? We say 2x. And you'll notice here in a little bit, I'll tell you the method we use. It makes this so much simpler. All right. And a notation for antiderivatives is convenient for us when we take the derivative of something to have a dx at the end, so we knew what we took the derivative of. So if we took the derivative with respect to x, it was convenient for us to write differentials with a dx at the end, if you remember that, because we knew it was a differential, it was the derivative with respect to x. In the same way, when we take integrals, we like to put a dx or whatever we're taking the integral with respect of, so we know what variable we're changing, what powers we're changing on what variable. All right, so the operation for finding all solutions of this equation is called antiderivative differentiation or indefinite integration, and it's denoted by the sign that I've already showed you that looks like a fancy S. All right, a little bit of vocab is the function that's getting the integral taken of is called the integrin. The variable of integration is, again, our dx, just like when we were taking the derivative. And the constant integration we already had is always c. All right. So example 2 here. Describe the antiderivative of 3x. All right. So the antiderivative means the integral. So we're gonna rewrite 3x as just like derivatives. All right. We'll pull our constant out and multiply it by our integral of our variable. So what is the integral? So if I were to take a derivative and just get x, I would have had to have something first. All right, so actually the shortcut for taking integrals is we're going to increase the power by 1 and then divide by our new power. So we're going to have 3 times x squared over 2. That is the shortcut right there. They're not really the shortcut. That's the way to do it. You increase the power by 1, so 1 plus 1, and then you divide by our new power. Because if I were just to take the derivative of x squared over 2, I'm going to get x. I bring my power down, subtract the power by 1, so I'd have 2x to the first power over 2, and this would cancel out. All right? So what I'm telling you is you increase the power by 1, and then you divide by your new power. And then again, just to finish this derivative, then we multiply, so we're going to have 3 halves x squared. Okay? That's what it meant by rewrite, integrate, simplify. My rewriting part was right here, pulling my constant out. Okay? Example 3. The integral of x to the negative 3 dx. Again, there's my rewrite part. I'm going to increase my power by 1, so I'm going to add 1. I'm going to have, oh my, hate it when it does that. Okay, smartboard messed up a little bit there. So I have the integral dx. There we go. I'm going to increase my power by 1. I'm going to add 1. So I'm going to have x to the negative 2 power, and then I'm going to divide by my new power. So my integral then is x to the negative 2 divided by negative 2 plus c. Don't forget our constant of integration. All right. Same thing for the square root. So let's rewrite it. The integral of x to the 1/2 power dx. Let's increase our power by 1, so we're going to add 1. I'm going to have x to the 3/2, and we need to divide by 3/2. Now let's simplify. When we divide by a fraction, we really multiply by its reciprocal. So I should be able to multiply by 2/3. So it's 2/3 x to the 3/2. And that's it for that right there. That plus c is our answer. Don't forget our plus c. And the last one then is the integral of 2 sine dx. All right, so let's pull our 2 out. Take the integral of sine of x dx. The integral of sine, well, what would we have to take? The derivative of sine of what to get sine is actually negative cosine. The derivative of cosine is negative sine. So we would have had to take it times. We would have had to have a negative cosine in order to take the derivative to get a positive sine. And if you're confused by that, you can always go look back at your cheat sheet here, and it says the derivative or the integral of sine is negative cosine, and the integral of cosine is a positive sine. So that's all there on your cheat sheet for you. All right, and moving back over here to our problem, we still need to multiply by 2 and add our constant. So we have a negative 2 cosine x plus c. A couple more examples real quick before I run out of time. The integral of dx, well, that's just saying the integral of 1. It's not there, but we can take 1 times dx. All right, they're asking the integral of 1. So increase my power by 1. So I'm at a power of 0, so my power is going to increase by 1. So I'll have x to the first and divide by my new power, which is 1, plus c. Obviously, you don't have to write these 1s here. All right, that's all that is. The integral of dx is just x plus c. All right, for b, to rewrite that one, all right, let's take the integral of x plus the integral of 2 x dx, dx. Here we're going to take the derivative or integral with respect to x. So my first one, I'm going to increase the power by 1. So I'll have x squared. I'm going to divide by my new power, divided by 2, plus increase the power by 1 and divide by my new power, plus c, my constant of integration. And for the last one, works the same way. The integral of 3x to the 4th minus the integral of 5x squared plus the integral of x. And again, we can pull our constants out. 3 times the integral of x to the 4th minus 5 times the integral of x squared plus the integral of x. Okay? Well, when we take the integral, we're going to have 3 times the integral. So we increase my power by 1, divide by my new power. So I'm going to have x to the 5th over 5 minus 5 times x to the 3rd over 3 plus x squared over 2. And again, we'll simplify here. So I'm going to have 3/5 x to the 5th power minus 5/3 x to the 3rd power plus x squared all over 2. That's all the time I have for this video. I hope this helped with integration, and we'll see you in class tomorrow.